Good morning, students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today's our topic is Attribute Selection Measures in Decision Tree. In previous class, we have already started our decision tree and you know about the decision tree very well. Decision tree is a non-parametric supervised algorithm which is very useful for both the classification and regression also. In decision tree, it will contain some root node, some splitting nodes, then decision node, pruning, some branches. That means in decision tree, after using all these things, we will get the sum of the result and we will reach to our sum of the decision. So on that basis, we will cover today some attribute selection measures in the decision tree. This how do decision tree work and attribute selection measures we will cover in today's topic. So how do decision tree work? Actually, a decision of making strategical splits heavily affects a tree's accuracy. Whatever you are taking the decision related to your problem related to your task. So all these things, it will affect on your accuracy, tree's accuracy. And these decision criteria are totally different for the classification and the regression tree. And you know very well the decision tree is working for the supervised algorithm. That means where we have to train our models and then we have to do some experiments also on it, and after that we will get some of the result and then we will reach to our decision. So these trees are containing some branches, some nodes, some decision nodes, then some we will split the sum of the nodes. So all these things decision related to our decision tree, and these decision trees use some multiple algorithms to decide to split a node into two or more sub-nodes. That means for splitting these nodes, this decision tree will use some multiple algorithm. That means which node we have to split, which node we have to use for particular decision, and which how many nodes we have to split. Everything will decide by the decision tree. And the creation of the sub-nodes increases the homogeneity of resultant sub-nodes. In other words, we can say that the purity of the node increases with respect to the target variable. The decision tree splits a node on all available variables and then select the split which results in most homogeneous sub-nodes. Actually, the decision tree splits your nodes which are available variable, and it will select the splits on the before your results, and the algorithm selection is also based on the type of target variable. Let's look at some of the algorithm which are used in the decision tree, like ID3. ID3, which is the extension of the D3 algorithm. Then C4.5, it is the successor of ID3 algorithm. Then CART algorithm, which is classification and regression tree algorithm. Then CHAD, then chi-square automatic interaction detection performs multi-level splits when computing classification trees are there. And then MAS means multivariate adaptive regression splints. These are the decision tree algorithms where we will use for the splitting purpose for reaching our target. Then the ID3 algorithm built decision trees using the top-down greedy search approach through the space of possible branches with no backtracking. That means in the ID3, we will not use our backtracking algorithm. We will use the top-down greedy search algorithm. And the greedy algorithm, generally it suggests that it makes the choice that seems to be the best at that moment. Now, which steps we have to follow in the ID3 algorithm? First, it will begin with original set, that is S, as the root node. On each iteration of the algorithm, it iterates through the very unused attribute of the set S and calculate the entropy and the information gain of this attribute. First, you have to start with original set S. That means S is your root node. It will be your root node. And then you have to iterate your unused attribute of the set S. And then on that basis, you have to calculate your H and your IG. H means is your entropy and your IG means information gain. After that, it will select some attribute which has the smallest entropy or the largest information gain. The set S is then split by the selected attribute to produce the subset of the data. After that, you have to split your selected attribute, whatever you have selected attribute, then you have to split that attribute for producing the subset of the data. And the algorithm continues to recur on each subset. That means considering only attributes never selected before. Then we will see attribute selection measures. Now, if the dataset consists an attribute, then deciding which attribute to place the root or at different level of the tree as internal nodes is the complicated step. Definitely, in decision tree, you have n number of attributes and then you have to decide which attribute to place at the root or which attribute you have to place in the different level of the tree. And by just randomly selecting any node to be root, can't solve the issue. If you choose any node as a root node, it will create some difficulty for solving the issue. So definitely you have to search only that attribute which is very useful and which is very helpful for to reach our target. And by just randomly selecting, definitely it will not solve your issue, but it will increase your complications in that particular problem. And if you follow random approach, it may give us bad result with low accuracy. Definitely, for example, you have selected only any attribute as a root node, and then you have to reach definitely for the conclusion. You have to reach to your target. So if you selected randomly any attribute as a root node, so definitely it will give the bad result and that will give the low accuracy. That means it will show some low accuracy for the your conclusion. And for solving this attribute selection problem, researchers work and devise some solution, and they suggested some criteria. And these criteria are entropy, information gain, then Guinea Index, gain ratio, reduction in variance, and the chi-square. And these criteria will calculate values for every attribute. Whatever you use the attribute in your decision tree, and by using these things, you can calculate your values. And the values generally are sorted and attributes are placed in the tree by the following order. And attribute will be with high value, and in case information gain is placed at the root. And while using the information gain as a criterion, we assume attributes to be categorical, and for the Guinea Index, attributes are assumed to be continuous. If you are using the information gain, at that time your attributes will be categorical. And if you are using the Guinea Index, then at that time your attributes will be in the continuous approach. Now, Entropy. Actually, entropy is the measure of the randomness in the information being processed. The higher entropy, showing that the harder it is to draw any conclusion from that information. If your entropy is higher, then definitely it will difficult to find out your conclusion. And for example, flipping a coin is an example of an action that provides the information that is random. If you are flipping a coin, definitely there are only two chances. Either you will get the head or you will get the tail. So this is showing the only what action you have taken for providing the information, and here information is providing randomly. This is your diagram. It is showing the h of x. This is showing probability of x equal to 1, and this is your entropy. From the above graph, it is quite evident that entropy h of x is 0 when the probability is either 0 or 1. Your h of x is 0 only when your probability is 0 or your probability is 1. And the entropy is maximum when probability is 0.1. You can check here. Entropy is maximum when your probability is 0.5 because it projects perfect randomness in the data and there is no chance if perfectly determine the outcome. And ID3 follows the rule, the branch with entropy of 0 is leaf node and a branch with entropy more than 0 needs further splitting. If branch with an entropy of 0, that means it will contain only leaf node. And if a branch with entropy more than 0, then definitely there will be need of the splits. We will need some branches also. Mathematically, entropy for one attribute is represented as E of S is equal to summation of I of 1 C P of minus P of I log of Pi base of 2. So here play golf, yes or no. Then yes value for S is 9, no for is 5. And here we have to find out the entropy of the play golf. And the value is entropy for 5 and 9. That means entropy of, we have to find out yes or no, or we can say entropy no or yes. And now we will keep the values. Entropy of no value for no is a 5 and value for S is a 9. According to this, you have to find out and you will get the entropy play golf is a 0.94. That means here S is showing that current state and Pi is showing that the probability of an event I of state S or percentage of class I in node of the state S. Now mathematically entropy for multiple attributes is represented as E of Tx is equal to summation of C belongs to X, P of C and E of C. Here again some play golf values, but here outlook we have to look for the sunny, overcast and rainy. And play golf there are two attributes again, yes and no. Then there are some values 3, 4, 2, 2, 0, 3 and then you have some values for the total outlook. That means we have to find out E of play golf and outlook. That means T of X. Now P of sunny into E of 3, 2. E of 3, 2. P of sunny. Then here is a probability. According to this, you have to put all these values. Then P of overcast into E of 4, 0. Entropy of 4, 0. Then P of rainy. Probability of rainy into entropy of 2 and 3. And after solving this problem, you will got the value. You got the value 0.693. Here T is your current state. T is showing your current state. and X is showing that selected attribute. It's showing as a selected attribute. Now, information gain. What is meant by information gain? Even we can denote as a IG. It is a statistical property that measures how well a given attribute separates the training example according to their target classification. Actually, it is one of the statistical probability property where you will train some of the attributes, then you will separate and you will reach to your target classification. And the constructing decision tree is all about finding an attribute that returns the highest information gain and the smallest entropy. This is the diagram of the information gain. This is showing the low information gain and this is showing the high information gain. That means you can see green color symbol are showing the low information gain, and here high information gain, it's showing the green color symbol. Now, information gain generally is used to decrease the entropy, and it computes difference between entropy before split and the average entropy after split of the data set based on your attribute value. Whatever you have attribute values, on that basis you have to compute some entropy before split and average entropy after the split. ID3, that means iterative dichotomizer decision tree algorithm, uses the information gain, and mathematically information gain is represented as information gain of T of X equal to entropy of T minus entropy of T comma X. RG of again play golf comma outlook, entropy of play golf minus entropy of play golf comma outlook, and all these things you have already found these values, and now information gain value is a 0.247. Now, in much simpler way, we can conclude that information gain is equal to entropy before minus summation of j equal to 1 to k entropy of j after. So, where before is showing as the data set before the split, and k is the number of subset generated by the split, and j comma after is showing that subset of j after the splitting. Now we will see Guinea Index. You can understand the Guinea Index as a cost function used to evaluate splits in the dataset. Actually, it is one of the cost function where we will use to evaluate some of the splits which are available in the data. And it is calculated only by the subtracting the sum of the squared probabilities of each class from 1. It favors larger partitions and easy to implement, whereas information gain favors smaller partition with distinct values. It favors larger partitions and it is easy to implement. Information gains smaller partition with distinct values, and Guinea Index is equal to 1 minus summation of I is equal to 1 to C P of I whole square. And Guinea Index generally works with the categorical target variable, that is success or failure. It performs only binary split, and higher value of the Guinea Index implies higher inequality or higher heterogeneity. Now, how we will find out the Guinea Index for the split? There are some steps. First step is calculate Guinea for subnodes using above formula for success P and formula Q, that is P square plus Q square. After that, calculate the Guinea Index for the split using weighted Guinea score for each node of that split. First, you have to calculate Guinea for the subnodes. Then you have to calculate the Guinea Index for split using the weighted Guinea score. Then cart, you have to use the cart, that is classification and regression tree uses the Guinea Index method to create the split nodes, split points. Here you have to use the classification and regression algorithm for splitting your points. Now we will see gain ratio. Information gain is based towards the choosing attributes with a large number of values as root nodes. It means it will prefer the attributes with large number of distinct values. And C4.5 is an improvement of the ID3, which is use the gain ratio, which is modification of the information gain, and that reduces its bias and use the best option. Actually, gain ratio overcomes the problem with information gain by taking into the account the number of branches that would result before making the split. It corrects the information gain by taking the intrinsic information of split into the account. Now let us consider, if we have a data set that has users and their movie genre preferences based on variable like gender, group of age, then rating and so on. With the help of information gain, you can split at gender. That means you can assume it has the highest information gain. And now variable, group of age and rating could be equally important with the help of the gain ratio. And it will penalize a variable with more distinct values, which will help us decide the split at the next level. That means what we will do, we will take one of the variable like gender, group of age, then rating, but now we will decide which attribute we have to split. For example, we split the gender, that means it will provide the highest information gain. Then after that group of age, then rating, that will provide the same information. That means same information gain ratio. So on this basis, we will split our data, and now we have the formula for the gain ratio. Formula for gain ratio is information gain divided by split information. That means information gain means entropy before the splitting minus summation of j equal to 1 to k. Entropy j subset after the splitting divided by summation of j1 is equal 1 to k w of j log of w of j base 2. Here before is showing the data set before the split, k is showing the subset generated by the split, and the j after is showing the j after the split. Now reduction in variance. Reduction in variance is algorithm which is used for continuous target variable which is showing the regression problem. Reduction in variance, it's one of the algorithm which is used for only continuous target variable, and this algorithm uses the standard formula of the variance for choosing the best split. The split with lower variance is selected as the criteria for splitting the population, and variance is equal to summation of x minus summation of x bar whole square divided by n. And the x bar is mean of values, and x is your actual value, and n is the number of the values. How many numbers are available in your task? So it will show as the n. And steps to calculate the variance. First, you have to calculate variance for each node, and then calculate the variance for each split as weighted average of each node variance. Now we will see the chi-square. Actually, we have already covered the chi-square in detail in previous classes, but still here it's very need. So the chi-square acronym CHAD stands for Chi-Squared Automatic Interaction Detector. Actually, it is one of the oldest tree classification method, and it will find out some statistical significance which is showing the difference between the subnodes and the parent node. We measure it by sum of the square of the standardized differences between the observed and the expected frequencies of the target variable. It works with the categorical target variable, success or failure, and it can perform two or more splits. The higher value of the chi-square, higher the statistical significance of differences between the subnode and the parent node. It generates a tree called CHAD, that means chi-square atomic interaction detector, and mathematically we can represent x square is equal to summation of O minus E whole square divided by E. X square is your square obtained. This is the sum of O is your observed score and E is your expected value. Now how we have to calculate the chi-square for the split? First, calculate the chi-square for individual node by calculating the deviation for success and the failure both. Then you have to calculate the chi-square of the split using the sum of all chi-square of success and failure of each node of the split. First, you have to calculate chi-square for each individual node by calculating the sum deviation. Then you have to calculate chi-square of the split using the sum of all chi-squares of success, or we can say failure of each node. Now, how to avoid or counter overfitting in the decision tree? The common problem with the decision tree, especially having a table full of columns, they fit a lot. Sometimes it looks like the tree memorize the training data set. If there is no limit stay set on the decision tree, it will give you 100% accuracy on the training data set. Because in worst case, it will end up making one leap for each observation. And this affects the accuracy. Accuracy when you have to predict the samples that are not part of the training set. And there are two ways for removing the overfitting. First one is the pruning decision tree, and another one is the random forest. Now, pruning decision tree. The splitting process results in fully grown trees until the stopping criteria are reached. In splitting process, you will get the result like fully grown trees. But fully grown tree is likely to overfit the data, leading to poor accuracy or on unseen data. That means this fully grown tree, it will show that there is a overfitting, and it will give the poor accuracy. You can see this is the pruning in action. Now it is your fully grown tree. After some time, it will reduce some nodes. That means this is your pruning tree. Actually, in pruning, you trim off the branches of the tree. That means what you are doing, you are removing your decision nodes starting from the leaf node such that overall accuracy is not disturbed. That means you will remove only those nodes which are not very usable, and it will not affect on your result. And this is done by segregating the actual training set into two sets. First, training data set D and validation data set is V. First, you have to prepare your decision tree using the segregated training data set D. Then you have to continue for trimming the tree according to optimize the accuracy of the validation of data set V. Now, this is your original tree. In original tree, you can say tier production rate, then reduced and normal. Again, there are two branches. Then none and astigmatism. Astigmatism. Then again there are two branches, yes and no. If it's a yes, then there is a age. Again there is a soft and none. Again spectacle prescription. Then again there are two branches. Again there is one branch, age. Then again young, not young. That like this is your original tree. But in prune tree, what happened? We have trimmed our decision tree, and we have removed that those branches which are not choosable. So here you can see tier production tree reduced normal. Again normal has only two branches. Then again spectacle prescription has two branches. That means we have removed this tree. We have removed this also. That means we have trimmed our branches. And above diagram, the age attribute in the left hand side of the tree has been pruned as it has more importance on the right hand side of the tree, hence removing overfitting. Now random forest. The random forest is an example of ensemble learning in which we combine multiple machine learning algorithms for obtaining the better predictive performance. But why its name is the random? Actually, there are two key concepts. One is the random sampling of training data set when building trees, and random subset of features considered when the splitting nodes. And a technique known as bagging is used to create ensemble of trees when your multiple training sets are generated with the replacement. And in bagging technique, dataset will be divided into n number of samples using the randomized sampling. Then using single learning algorithm, model is built on all sample. Later, the resultant predictions are combined using the voting or averaging in parallel. Random forest in action. See, you can see that here random forest is an action. Your tree values are continuously changing, and this graph is continuously changing. This is all about the random forest pruning trees, pruning tree. These are your references, so you can go through these reference. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.